Okay, Assalamualaikum and good evening class. So we shall start our class. You can hear me, right? Can you?
Yes,
Yes,
doctor.
madam.
Yes, madam.
Yeah.
So
Yes, madam.
before we start, okay, thank you. Because this day I got problem with the Google Meet. Sometimes they cannot hear my voice. Okay. Okay. So before we start the class, it is about your quiz too. Okay, as I mentioned, it will be postponed next week, the week 5. Okay, so quiz 2, which is the subtopic is 2.2 confident interval for the population mean. Okay, we will do the quiz on Monday. Okay, so the quiz 2 will be on Monday next week because I don't want to um, takes time during our virtual class. Okay, so it will be like last week we couldn't finish the subtopic. Okay, so we'll be on Monday. We start at 4. Okay, the method maybe will be similar as a quiz one. Means that you have to join the Google Meet and then on the camera. Okay, I will inform later the method, but the platform will be similar. Okay, it will be the Google Classroom. Okay. Okay. That's it for the quiz too. Okay. So when I already go through your quiz, but not yet mark the quiz. Okay, just go through. Okay. So I would like to remind regarding the assessment. Okay. You can help me by submit a very clear version of your answer scheme to me lah. Okay, it will be easy for me to mark later. Okay, and please try your best to submit in Google Classroom for the quizzes test. Okay, because if you submit to the WhatsApp, it will be problem. It is not a problem, but I afraid that I will lose your quiz, your answer scheme. Okay, if you submit to the WhatsApp, because I got many WhatsApp this day from the students, so I could be miserable later lah. Okay, so please try your best to submit in Google Classroom for the quiz. If not, I will give you my email, then you can email me your answer scheme. Okay, we try to avoid WhatsApp lah. Okay, we go to more formal platform. Okay. So that's your quiz 2, will be on Monday. Okay, so we proceed to the exercise 2.1. Okay, so I ask you to do the number 2 and also number 4. Okay, so the number 2 here. What is your variable for the number 2 here? Anyone? Variable?
Number of 100 pieces of wood.
100 pieces of wood. Anyone? Anyone else? Variable? Other than that, what is your variable? Variable is a data that been collected. What kind of data that we collect here? From 100 pieces of wood, that your subject. Okay, the data come from the wood. So what kind of data that we collect from the wood? It is
Random number.
Length of the wood.
length of the wood. Okay, length of the wood. Okay, so this is your variable, length of the wood, your variable. Okay, so previously we already discussed how to define the variable from the question. Okay, one of the way we define from the calculated value. Okay, the value given in that question, if there is no data given, okay, if you have some value in that question, so the value given in that question from what? It was calculated from what? Were calculated from what? Okay, in this case, we have mean of length. So the mean here was calculated from the length. So length should be your variable. Okay, That's the easiest way to define what kind of variable in that question. Okay, so the random number of 100 pieces, 100 here is your, so the first step before we go to the solution, the first step is to extract the information given. Okay, extract any or all significant information given. So how do we extract? We convert into mathematical writing. Okay, so mathematical writing means that we use notation lah. Okay, if involve notation, then we write the given information in terms of notation. So it will be easy for us to read the information later. Okay, when we go to the substitute the value in formula, then it will be easy for us if we write using the notation. Okay, so 100 pieces here, that's your
Sample.
sample. Notation,
N.
it is n, so small n. The sample mean of length is 1.06. So 1.06, it is
X bar.
okay. So it is here S bar. Okay. So it is clear that we have the sample mean. So clear that we have sample mean. Okay. So let's say that there is no word sample here. 1.06 still S bar because 1.06 here, it come after we have sample here. Okay, it come after we collect the sample. Okay, so 1.06 still S bar lah if there is no word sample here. But here it is clear that we have sample mean. So S bar. Okay, and the sample standard deviation is a 0.08. So 0.08, it is your
S.
S. Okay, so find the first question, find a 90% confidence interval for the mean length of all wood. Okay, so it is clear that confidence interval. Okay, for the question that involve confidence interval, it will be mentioned in that question. You have to construct the confidence interval. There is no implicit word we use to show that you have to construct the confidence interval. Okay, it will be crystal clear that you have to construct the confidence interval. Okay, we will use word like this, construct the confidence interval. It is very clear that you have to construct the confidence interval for the mean length of all woods. Okay, so mean length, all wood here, population, because we have word all. So mean for the population, it is a mean. So we have to estimate population mean. Okay, we have to estimate mean. Okay, we construct the confidence interval for the mean. Okay, that's how we identify the parameter that we need to estimate, and also based on the information given. Okay, what kind of estimator that you have in that question? Okay, because estimator also what we call one of the clue how what parameter that we are going to estimate. Okay, by looking at the estimator given in that question. Okay. So we go to the A. Okay. What happened now? Okay, so we have all the information that we need. We already extract all the information. Then we go to the choose which formula that we need to use. So the first condition, we need to know whether sigma is known or unknown. So in this case, known or unknown?
Unknown.
Kenapa unknown?
Unknown.
Because
Why?
standard deviation. Yes, it gives value of standard deviation only.
Standard deviation could be sigma. Why unknown? Why we have unknown here? Why? Why the sigma is unknown? Why we conclude here sigma is unknown? If you said that because of standard deviation is given, it is incorrect lah, because standard deviation could be the sigma. Why? Why we conclude here sigma is unknown? Already explained last week. Why we said we have condition sigma is unknown, why we said we have condition sigma is known. So in this case, we conclude that sigma is unknown. Why?
Is given that it is a sample standard deviation. So the sigma is supposed to be population.
It means that we don't have the value of sigma in this case. Okay, there is no value of sigma in this question. Okay, we are not given the value of sigma. We just have the S. Okay, we just have the sample standard deviation, which is S. There is no value of sigma. Okay, that's why we conclude here sigma is unknown. Okay, so should be clear lah. Okay, why we conclude sigma is unknown, because there is no value of sigma. We couldn't find anywhere here in that question. Okay, so that's the first condition. The second condition, when unknown, we need to know what is our n. So in this case, we have larger n or small n?
Larger.
N equal to 100, which is greater than 30. So we use formula with the Z and S. Okay, so we need the 90%. Of CI. So alpha equal to, what is your alpha?
0.05.
Alpha is 0.
1.
Alpha is 10%, 0.1. Then divide by 2.
2.
So 0.05.
5.
So in your statistical table, we get 1.624.
6449.
So we substitute in our formula. We already have our S bar. So 1.06 plus minus the Z value and then the S value. So you will get lower bound.
$1.0468.
1.04.
68.
Upper bound.
1.073.
32.
1.0732.
We put unit.
CM.
cm.
Okay, so you should get lower bound and upper bound. So we write the lower bound first and then upper bound. Okay, so the next one, interpret your answer. Okay, so there is two ways in order to interpret the answer. Okay, the first one we talk about the confidently. The second one we talk about the probability. Okay, you can write either one. Okay, it's up to you. So we are the population mean length. Or you can write based on the probability. Okay, so it's up to you. So the probability of the population mean length of all woods is between your confidence interval is 0.9, because the confidence level here, okay, so the confidence level here represent the probability of your confidence interval. Okay, any questions so far?
No, Doctor.
No.
Okay, we go to the B. So B, we need to find what is the width of this confidence interval. So how do we calculate the width of the confidence interval?
B minus A.
Upper bound minus lower bound. So B minus A. Other than that, how do we calculate the width? This is the easiest one. Okay, this is the easiest one. How do we calculate the width? It just upper bound minus lower bound. Then you get the width of your confidence interval. Okay. Other than that, how do we calculate the width of this confidence interval?
2E.
The width equal to 2E. How to calculate the E?
E equal to Z times S over square root of N.
So E is your the second term here. This is your E. The Z distribution, the Z value multiplied with the standard deviation of mu. Okay, that's your E. So similar, you can use the first formula here or you can use the second one here. Okay, either one, but you have to know both. How to calculate the width, you have to know both. Okay, let's say that I have a question. Let's say that we decrease the n here. So we change to the n equal to 50. What happened to the width of your confidence interval? It become larger or smaller? If we change the n,
Become larger
More.
why larger?
because by decreasing the decreasing the sample, which means the error will become bigger.
Okay, so because larger because when we decrease the n, your E will be increased. Okay, so your E will be increased means that your data will be like far from each other. That's why the width become larger. Okay, that's good. Okay, so we go to the question 4. Okay, the result of the stress test, okay, is known to be normally distributed random variable with the mean mu and standard deviation 1.3. It is required to have a 95% confidence interval of mu with total width less than 2. So find the least number of tasks that should be carried out to achieve this. What is the variable here? Variable?
Number of tests.
Stress test.
Result of a stress test. X.
Result of stress test. Okay, result of a stress test. That's your variable. The X here represent your variable. Number of tasks, that's what we call this your subject. The test here is your subject. Okay, the data that we collect from the test is a result. Okay, so test is your subject here. Okay, so what is 1.3 here? The
Mu.
1.1
Sigma.
sigma. Okay, so it is required to have 95%. So you have the confidence level here with the width less than 2. So we have width less than 2. So find the least number of tests. So the number of tests here, that's your
N.
N. So here we need to find N. Okay. So we have sigma in our question here. We get sigma from this question. Okay. Means that, okay. Not that, okay. Confidence interval for the mu. Okay. One of the keyword here. Okay. So means that we need to find this N by using the concept of confidence interval for the mu. Okay, and another keyword here because of you have sigma in this question. Okay, so when we go to the 2.4, the proportion, okay, you will find another formula to find the N. So basically, we will have two different formula to find the N. First, by using confidence interval of mu, and second, by using confidence interval of proportion, the pi. Okay, so how do we know which formula that we need to use? It depends on your question here. What kind of information that we can get from that question? Okay, if you have the sigma like this question, means that we will use the confidence interval of mu. Okay, if you have proportion, the P, then we have to use confidence interval of proportion. Okay, so you will have N Z alpha over 2 and sigma divided by E and then square. Okay, so we do have alpha from the confidence level. We do have sigma here. Okay, or sometimes instead of sigma, you will have S. Okay, if you have the S, then you just substitute here with the S. Similar formula but different notation only. Okay, and then we need the E. Where is your E here? How we get the E from here? We need the estimation error
The width.
from the width. So you are given width here. So we use the information of the width to find the E. So width less than 2, width is a 2E less than 2. So E equal to 1. So we get E equal to 1. So just substitute E here with the 1, then you will get your answer. Okay. For the N is a whole number. So we cannot have the continuous value for the N. Okay. So the final answer must be round up to the next whole number. You should get 7, right?
Yes.
Should get, after you calculate this, you will get 6 point something. Okay. But N must be whole number. So we round up to the next whole number, which is 7. Okay. Final answer must be whole number. So 7 times. Question so far?
No.
Okay, you should be ready for your quiz too. Okay, so we go to the next one. Let me clear these pages. Okay. So 2.3, we have confidence interval for the difference between two population mean. Okay, so notation that we have here. Okay, you will have mu1 minus mu2. Okay, so estimate the confidence interval for the difference between two population mean of independent sample. Estimate the difference between two population mean of dependent sample. Okay, so what is independent? What is dependent sample? Okay, so both we have two set of data. Okay, so independent sample means that we have two set of data from two different set of subject. Okay, let's say that we are talking about the aircon. Okay, we try to get the data about the lifetime of the aircon. Okay, aircon from company A and aircon from the company B. So we collect the data from the aircon company A, and then we collect the data from the aircon company B. So totally two different company, totally two different set of subject, aircon of A and aircon of B. So you are dealing with the independent sample. Okay, so you are dealing with the independent sample. Two set of data from two different set of subject. So subject could be anything lah. It could be people, it could be a thing. Okay, so independent sample. Okay, so when we have independent sample, the data could be influenced by the characteristic of your subject. Okay, the data could be influenced by the characteristic of the subject. Okay, so some study, they want to discard, okay, or they want to reduce the effect of the characteristic of the subject to the data. Okay, they try to reduce the influence of this characteristic of the subject to the data. So what they do, they use dependent sample. So dependent sample, we still get two set of data, but from same subject. Okay, so just now aircon, okay, means that now we are using similar aircon from company A, for example. Okay, and we try, let's say that we try to we try to implement the new material on that aircon. Okay, so we try to see the difference between old material and also the new material on the same aircon. Okay, because we try to reduce the characteristic of the subject to the data. Okay, so we implement on the same aircon to get the data of the aircon use what we call old material and the new material. Okay, so basically you will have this. So aircon, so old material and then new material. Okay, we try to see the effectiveness of the new material. So we compare with the old. Okay, we can use the dependent sample. Okay, so we have two set of data, old material and new material, which is coming from same subject. Okay, the subject now is a aircon. So still two set of data. Okay, so when we have dependent sample, okay, when we need to analyze the dependent sample, we need to combine these two data, old and new. So how do we combine? We calculate the data different. We calculate the data different. Okay, it can be old minus new data, or it can be new minus old data, depends on the question. Okay, so the rest of the analysis is based on the single data only, the data different. Okay, so notation that we use for the what we call dependent sample here is a mu D. So mu D represent data different. Okay, so the analysis based on the data different, not from these two set of data. Okay, it is from data different. So you will get S bar, you will have SD, S bar D and also SD. So D represent data different. Okay, so you need to know what we call, you need to know how to distinguish between independent sample and also dependent sample. We have some clue. Okay, we do have some clue to distinguish between these two samples. Okay, because some from the experience, let's say that we have a dependent sample, the question of the dependent sample. Some students misinterpret that one. They go to the independent. The whole thing will be 0. Okay, because it is about different formula, different value that we use. Okay, so be careful for this kind of question. Okay, so there is no rule what we call, there is no rule that this research should be independent or dependent. It depends on the research itself, whether we need to do the independent sample or whether we need to do the dependent sample. Okay, so we go to the independent first. Okay, so dependent sample, totally 2 different subject. So 2 different subject means that it will be 2 different population. That's why we do have mu1 and also mu2. Okay, so we have 5 different formula here. As I said, no need to memorize the formula, but you have to know which one for the unknown, which one for the known, which one for the n greater than 30, and also which one for the n less than 30. Okay, so the first condition that we need to know whether sigma is unknown or known. Okay, so if known, then we use the first formula with the sigma here. Okay, if unknown, the second condition that we need to know equality of population variance. Okay, equality of this population variance. Whether we have equal, whether we have unequal. Okay, so how do we know this condition? It will be mentioned in your question. Somewhere in your question, that the equality of the population variance, whether you have equal or unequal. If there is no this condition in your question, means that you have known, or maybe we are dealing with the dependent sample. Okay, so this condition will be given in your question until we discuss the chapter 3. Okay, so chapter 2 and 3, they are always related to each other. Okay, in chapter 3, we will discuss the hypothesis testing for the variance. Okay, you will need to test H0, this one, and this one is the H1. So you need to test this hypothesis, whether we have equal or unequal. So selagi we don't discuss that one, then this condition will be given. When we go through the hypothesis here, then sometimes you need to test whether we have equal or whether we have unequal population variance. Okay, it will be discussed later. Okay, so for now, it will be given in your question. We don't assume by ourselves. We don't assume by the value of S. Okay, because it is population, not the S. Okay, so after that, the third condition, it is your N. So both less than 30 or both greater than 30. Okay, it will not be contradict to each other. So whether both less than 30 or whether both greater than 30. Okay, so we look at this formula first. We have unknown equal population variance for the n less than, for the both n greater than 30 and less than 30. You need to calculate the SP. Okay, we have extra here, the SP. So SP is a pool standard deviation. So this is formula for the SP. Okay, for the unequal population variance for the case less than, okay, we have special formula to calculate degree of freedom of T. Okay, the whole thing here is how we calculate the degree of freedom of T. Okay, you can refer to your module. It is not clear from here. Okay, so the value of nu here must be whole number because we need to read from the statistical table. Okay, there is no continuous value. So what we do, round down the value. Let's say that after you calculate, you get, let's say 13.99. So round down the value, you will get 13. So we use 13 to read from statistical table. Any questions so far regarding the formula?
No, madam.
No.
We proceed to the exercise. Okay, so for the one-sided lower bound and upper bound, how do we choose the formula similar? Okay, we need to know what condition that we have. Okay, the formula that we have here, just a general formula. If you go through your statistical table, the latest version of the statistical table, we do have the formula for the one-sided, but that one is a general one. Okay, when we try to construct the one-sided, still we need to see what condition that we have and choose which formula that we need to use. The only thing that you modify is a alpha. No need to divide by 2. The alpha of your critical value, Z or T distribution. Okay. Okay, we go to the number 2 here. Okay. What is the variable? Variable number 2.
Burn rate.
Burning rate. Okay, burn rate. So this is your variable. Okay. So from the first sentence here, is there any information that we could write? So we have two different propellant. So two different propellant, propellant 1, propellant 2 means that here we have independent sample. It is two different subject. So two different population. Okay. So we have independent. And also we can determine based on the information given here lah, the data that given here. Okay, the second sentence. It is known that both propellant are normally distributed and have the same population variance. So how do we write the information? Same population variance. How do we write? It is sigma 1 equal to sigma 2. Okay, don't miss that one. Two random sample of 26. So 26 here, that's your, it is
And
Sample.
N for the both. Okay, so the sample mean and standard deviation of the burning rates for the both propellant are summarized as in table below. Okay, so it is clear that you have sample mean and standard deviation. So the mean here, it is your S bar, and standard deviation here, that's your S. Okay, so construct a 90% confidence interval on the difference in population mean. Okay, Another keyword or another clue that we can use to distinguish whether we have independent and dependent is the question here. So different in population means that you will have independent sample. Okay. For the dependent sample, you will have mean different. So it is different, okay? So different in population mean independent sample. If you have mean different, that is a dependent sample. So another clue that we can use, okay? For the problem 2 and problem 1. So in this question, we mentioned 2 first and then 1. So means that problem 2 here, the first population. And problem 1, second population. Okay, because in your question, we mentioned 2 first and then 1. Okay, if the question didn't mention anything, for example, that for the both problem, okay, for the both problem, so it's up to you. You can do 1 minus 2 or you can do 2 minus 2. It's up to you. But if the question already specific which one first, then we have to follow. So in this case, we need 2 and then 1 and then interpret the answer resulted. Okay. So 90%. Okay, so we need problem 2 and 1. So you can write here. We need 90% Ci of mu2 minus mu1. Okay, so that we aware that in our calculation letter, it should be problem 2 and then problem 1. Okay, so when you write your formula, you can implement that one. Okay, so to choose the formula, the first condition, do we have sigma in our question? Sigma is known or unknown?
Unknown.
Okay, and then equality of population variance, we have equal or unequal?
Equal.
Equal. The n larger or small?
Small.
So we use formula with the T, SP, and S. Okay. So S bar. So now, because of we need 2 first, then you can write here S bar 2 minus S bar 1 plus minus your critical value. And then you have SP because we have equal. And then we have the standard deviation here. Okay, so the new here, it is N1 plus N2 minus 2. Okay, so you can write your formula like this so that we aware that it should be 2 first and then 1. Or you can write like usual, S bar 1 minus S bar 2. But you have to take note here, S bar 1 is a problem 2, S bar 2 is a problem 1. Okay. So I need the answer. 4 point something. Double bound.
7.
4.76.
4.7.
697.
The upper bound. 7 point.
43.
4.
4303.
4303. Yes. Good.
I got different.
What you got? 4553 like this?
Yes.
Yes. I got like that.
So check your decimal places. Are the difference, if you get difference, it could be the decimal places that you use. Okay, so mm, four, 7, and 4, 5, 5, 3. Unit? Do we have unit here?
Per sec, cm per sec.
And then interpret the answer resulted. So how do we interpret similar? Because of we have both are positive. Okay. Usually when we calculate for the difference of population mean or population proportion, sometimes you could get negative confidence interval. It is okay to be negative, but for the interpretation, it will be different. Okay. If you have negative confidence interval, we need to interpret in this form so that it will be significant. Okay. So for example, let's say that here we get negative. Okay, so how do we interpret? Let's say that we have negative for the lower bound, or maybe both are negative. Okay, so so this interpretation is for negative confidence interval. Confident that of problem 2. Okay, so we have to mention the lower bound first. So without the negative value. So okay, so this is how we interpret if we have negative confidence interval. Okay, doesn't for lower bound or maybe both. Okay, if you have positive, then we interpret as what we did for the single population mean. Any question?
No, madam.
So we proceed to the next one. Dependent sample. Okay. Okay. Okay, so dependent sample, as I mentioned, we have the two set of data from same subject. Okay. For example, here we have pre-test or post-test study. Okay. We have before and after an intervention or treatment. Maybe we have like, we try to discuss the effectiveness of safety program. So the data that we collect before we implement the safety program and after we implement the safety program. Okay, the data could be anything. Okay. Other than we call it as a dependent sample, another one is a PET data. Okay, all version we use PET data. Okay, so PET data means that dependent sample. Okay, so as I mentioned, we need to combine two set of data into one single data. So how do we combine? We calculate the data different. Okay, so the rest of the analysis is based on the single data. Okay, the data different. So that's why the formula similar as a population mean, single population mean. But the different is a notation mu here. Okay, so now we have mu d. So d refer to the data different. Okay, so how do we choose the formula? Similar, we need to know whether sigma is known or whether sigma is unknown. Okay, if unknown, then we need to know n less than 30 or n greater than 30. Okay, the rest similar because now we have a single data set. Okay, so we go to the example, the exercise here. Okay. Okay, so the number 1 here. What is the variable? Variable. It is
Efficiency.
efficiency.
Time.
Time should be time. Time of what? The data is about time. Time of what?
Time of retrieving an image from a library slide.
Time to retrieve the image. Time retrieving the image from slide and also the computer database. Okay, from the slide, library of slide and also computer database. Okay, so the time here, okay, were collected from computer professional. Excuse me. 8 computer professional. Okay, so they try to retrieve the image from the slide and digital, and the time were recorded. Okay, so variable is a time. So based on the data itself, okay, so you should know that we are dealing with the dependent sample because we have 2 sets of data from same subject. Okay, so let's say that there is no row here, there is no subject mentioned here. Okay, tak ada kat sini, this first row is not here. So how do we know that we are dealing with the dependent sample? Okay, so we have the keyword here. An experiment was conducted in which 8 computer profession, okay, medical professional were timed both while with retrieving an image from library and also retrieving the same image from computer database. So means that we get those 2 data from the same professional. Okay, so that's why we have dependent sample. Okay, so assume that, okay, normally distributed, find the 95% confidence interval for the true mean difference. So another keyword is mean difference. Okay, so mean different, we have the dependent sample. Different in mean, independent sample. Between slide and digital. So between slide and digital means that the data different, it is slide minus digital. Okay. Okay, so we know that it is a dependent sample. So we need to choose the formula. Do we have sigma here?
No.
No. Okay, so the data here, it is from the 8 professional, only 8, not from all the professional. So it is sample data. So anything that you calculate from the data different here, okay, from the data different here, you will get sample value. So S bar D and also SD lah. Okay, this is a 2 value that we need. So there is no sigma, then sigma is unknown. And your N, small or larger?
Smaller.
Less than 30. So we use the formula here. Okay. And then interpret your result. The lower bound, the answer. The process similar as a confidence interval for the population mean. What do you get for the lower bound?
I got 6.952.
9, 5,
2.
only.
9524.
2, 4. Upper bound?
28.798. I don't know.
798.
7976.
7976. Okay. So means that you round up lah. Okay. So make sure that you have 4 decimal places. Okay, not the 3 decimal places. Okay. So 4 decimal places. Do we have unit here?
Second.
Second.
Second. Okay. So interpretation similar. Any question? Okay. So we go to the 2.4. Okay. Let me clear this out. Okay, so confidence interval for the population proportion. Okay, so what is proportion? So proportion is a probability of something or percentage of something. Okay, so that something most of the time is your variable. Okay, let's say that, okay, so first that you have to know, we use proportion when we have qualitative data. Okay, let's say that we are talking about number of defective item. Okay, so we have about 100 sample and then we need to study, okay, number of defective item. So the data that you are going to collect, first item, defect or not. That's your data. Second item, defect or not. So that's a qualitative, okay, qualitative data. So at the end, you will calculate the number of defective and the number of non-defective, for example. Okay, so what we have here is a frequency data. So we will go to the proportion. Okay, so proportion, it is for the qualitative data. Mean and also variance, they are for the quantitative data. Okay, so proportion, you will have probability of something or percentage of something. For example, percentage of defective item or probability of the defective item. Okay, so because of that, okay, so population proportion here, notation is pi. Okay, we use pi as a notation. So because of proportion here is a probability of something, then your pi here, it is between 0 to the 1 only. Because of probability. Okay, if you have the percentage, we need to convert into probability. Okay, so estimator for the pi, we have P. So sample proportion denoted by small p. So sample proportion. So similar, it is probability. So it is from 1 until 0. Sorry, from 0 until 1. Okay, so the objective here to estimate the confidence interval for a population proportion and to estimate the sample size. This is another formula that we are going to use to calculate the sample size. So in this case, you are given P. Okay, so that we know lah, we have to use this formula to calculate for the N. Okay, so for the proportion, we have single formula only. So there is no condition to choose the formula because we have single formula. As long as you know that we are dealing with the proportion, then we go to this formula. Okay. So we have the P as an estimator for the pi, and then we use the Z distribution for the pi, and then what we have here, standard deviation for the pi. So the second term here, that's how we calculate for E. So similar lah, okay. So we have P equal to X divided by N. So X here, number of success, okay. So if the success item defective item, then X here is the number of defective items. So depends on your question, what is your variable, okay. So P probability of success and Q here probability of failure, okay. So both probability, so must be 0 until 1, okay. So this is how we calculate for the N. So you need to have P in your question lah, so that we can use this formula to calculate for the N, okay. So note that if the sample proportion is not given, the value of sample proportion is considered equal, okay. If P, there is no P given in your question, or maybe there is no S in your question, so we cannot find the P, then we assume that probability of success equal to the probability of failure. So 0.5 for each. Okay, so in that case, you can assume if we don't have the value of P in our question. Okay. Okay, for the one-sided lower bound and upper bound, single formula, so means that it just modified the alpha. Okay, but the confidence interval for the pi here, it is between 1 to the 0, between 0 to the 1 only. Okay, so if you calculate for the one-sided lower bound, we calculate for the A only, automatically upper bound equal to 1. Okay, because the maximum value is 1. Okay, if we calculate for the one-sided upper bound here, we calculate for the B, so automatically lower bound equal to 0. Because minimum value is 0. Okay, so that's the difference between population mean. Okay. We go to this exercise. You can interrupt me if you have any question. Okay. So the cure rate for the standard treatment of a disease is 45%. Dr. Amani has introduced her new treatment which she claimed is much better. So she tests the new treatment on the 50 patients with the disease and cure 30 of them. Okay, what is the variable here? Variable?
Cure rate.
Cure rate. So variable is a cure rate. So here we have percentage of something. When we have percentage of something here, then we know this is proportion value. So you should know that here we are dealing with the proportion. Okay, so that's how we know. Okay, you have like percentage of something, you have probability of something, or you have the number of success. Then we know that we are dealing with the proportion. Okay, so we extract the information first. You have the standard treatment here, you have the new treatment. So totally two different things. Then you can write here, standard treatment and new treatment. Okay. So we have 45. Dr. Amani has introduced her new treatment which she claims is much better. So she tests the new treatment on 50 patients and then cure 30 of them. What is 50 here? What is 50 here?
N.
N
And for what?
number sample.
Number of sample untuk
So,
new treatment. New treatment. So number of sample for new treatment. So she tests the new treatment on 50 patients. So N for the new treatment. And then cure 30 of them. What is 30 here? What is 30?
X.
As number of success. So the success here is how many people get cured. So we have 30 people get cured. So that's a success. So 30 is S. What is 45 here? 45%.
Q.
And apa?
A.
P. Okay. It cannot be mu. Okay, cannot be mu. Because so here we have percentage of cure rate. So when it is a percentage of cure rate, definitely it is a proportion. But now we need to know it is a pi or p. Okay. So what we have here is a new treatment. And then 45 here is a cure rate of the standard treatment. So means that now currently in this question, currently we already implement the new treatment. So means that the standard treatment is something that already happened before. Okay, so this 45%, it is a cure rate for the standard treatment. So that standard treatment is something that already happened. So it is population. Okay, if you have value that represent past record, past study, anything that already happened, they are population. So 45 here for population. So because of percentage of something, it is proportion. So 45% is a population proportion. Notation? It is? Pi. So pi for the standard treatment. So when we write it as a pi, we need to convert into probability. Okay, so 0.45. Any question?
No question.
Okay. So A, find the sampling distribution of the cure rate of the disease. So A is not in the syllabus anymore, then you can delete that question. Okay, so B, construct a 99% confident interval on the cure rate of the disease for the new treatment. Okay, so we need for the cure rate of the disease for the new treatment and give a comment. Okay. So how do we know here we need to estimate the pi? Okay, how do we know the confidence interval here, that one for the pi? Okay, so we need for the cure rate. So the only information that we have related to the cure rate is a proportion. Okay, you have the X, the number of success. So number of success related to the proportion. Number of success and sample size can give you the P. So the only proportion related to the cure rate here is a proportion. Then we know. Okay, this confidence interval we use to estimate pi. Okay, so that's how we identify what variable that we estimate. Okay. So we need 99% confidence interval of pi. Pi for the new, not pi for the standard treatment. Okay. So we have single formula. Okay, so what is your P for the new treatment?
0.6.
0.6. So it is 30 divided by
50.
50. So alpha equal to 0.01. Baca pelik dulu. Okay. So Z 0.05 you get 2.57.
5758.
Okay. So lower bound you get
0.4215.
bound
0.7785. Is it correct?
yeah. Similar as previous class. Anybody got this answer?
Yes.
Okay, that's good. So correct lah. Okay. And then how do we comment similar? Okay. But for the proportion, okay, we have to, because proportion is a percentage of something. So it will be meaningful, it will be significant if we transform into percentage, the confidence interval here. Okay. So we are okay, so the rest similar, but here we just need to transform into percentage. Okay, the second question. If no estimation of the sample proportion available, what does it mean? No estimation of the sample proportion available.
P equal to 0.5.
P equal to 0.5. So no estimation of the sample proportion available means that we don't have the P. So what to do? We assume 0.5. Okay, if this statement is not here, then we use the above P, which is 0.6 from the above. Okay, so how large the sample of patient would be if we are 90% confident that the estimation error is 5%. So error in percentage, then we need to convert into probability. Okay, so here we have P. Then we need to use formula for the confidence interval for proportion lah. This one to find the N. Okay, you should get 217. The N? The? 271?
271.
271. Okay, so you will get 270 something, I think. Okay, then we have to round up to the 271 patient.
Yes.
Any question?
No, madam.
Kita pun dah penat. Okay, so I repeat, quiz 2 will be on Monday. Okay, I will inform the method. Okay, I'm still not sure whether we are going to use the same method as a quiz 1, where you need to join the Google Meet and on your camera. Okay. If not, I will just share the question in Google Classroom and then you do by your own and then submit. Okay. I will inform later the method. Okay. So the quiz 2 will start at 4 p.m. lah during the class time. Okay. So that's all for today. Thank you, class. See you next week, insyaAllah.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Okay.
Thank you, Doctor.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Okay.
Thank you, madam.